In this short video, we're going to look at a couple of examples where we estimate the value of a limit numerically. So let's try to estimate the value of the limit as x approaches 2 of x squared minus 4 all over x minus 2. Well, what is our idea? We are going to take values of x which are close to 2 and on either side of 2 and try to look for a trend. We're going to take values which are smaller and smaller, or closer and closer, to 2, and see if the resulting numbers are approaching a single number. So that's what I did. I chose these x values. I used some calculating tool to calculate what the y value would be. And it looks like, whether I approach from the left or from the right, that the y coordinates, or the function values, are getting closer and closer to 4. So this is still really just an educated guess, but all of the evidence points to that. So let's look at a second example, which is a little bit more complicated. I'm going to take the limit as t approaches 0 of radical t squared plus 4 minus 2 all over t squared. Now, when I start taking some small numbers, I can see that my function value is pretty much stuck at 0.25. So if I only use these small values, then I may think that the limit would be 0.25. But if I continue to get closer to 0, taking even smaller numbers, suddenly I'm not exactly at 0.25. And in fact, when I use 10 to the minus 7th for t, I get 0.22204, different from 0.25. And then if I choose values even smaller, I get 0. So this is an example where just simply substituting numbers in can lead you into trouble. There are limitations to the technology that we use. And so by just substituting numbers in, we can't really tell. What is the limit? Is it 0.25? Is it 0.22? Is it 0? Maybe the limit doesn't exist. So we do have limitations. We have with numerical approximations. And so we are going to need to develop some better tools for calculating limits. I hope you found this video on calculating limits numerically useful.